Our mission for today is to solve some one-step inequalities. We're going to be using the subtraction property of inequalities as well as the addition properties of inequalities, using one inverse operation to isolate our variable just as we did earlier this week with equations. So you can use the subtraction property of equality and subtract the same numbers from each side, and you will not change the integrity of the inequality. When I look at an equation or an inequality, so we did this with equations, now we're looking at inequalities, we're going to notice that some of them involve addition. Well, the inverse operation is subtraction, so we're going to take this first problem and subtract 8 on both sides. We're then going to find that we can, in that one step, isolate our variable, and we'll get n is greater than or equal to 11. Remember we talked about open and closed circles? Well, this one would be a closed circle. Just remind us of all those little details, because if we had to solve n graph, it needs to be a closed circle. On to our second problem. Again, I see addition. My inverse operation is subtraction. I then get x is greater than 3. The greater than symbol here would be an open circle. And I'm not graphing these just yet because we spent a good part of our time last session on that. Let's take a look at two additional problems. These are still addition inequalities. I see the addition sign. I will go ahead and subtract. Remember, when I subtract, I add the opposite, and that gives me negative 10 is less than or equal to x. But if you remember from last session, we're not done until we write our inequality with the variable first. X is greater than or equal to negative 10. There is your solution. I look at one more problem on this slide, and I see that I'm going to have 4, so I subtract 4 on both sides. If I have a positive, I reverse it and I subtract it out. Canceling it out, isolating my variable, I get n is less than 8, and that would be an open circle. Let's move on to the addition property of inequalities, which tells us that we can add the same number to each side. To solve an inequality involving subtraction, we'll just add. So I see n minus 15 is less than 3. So I'm going to again add 15 to both sides, canceling out. I get n is less than 18. If I had to graph this, I would find 18 on my number line. I would have an open circle, and I would shade everything in the less than direction. Remember, less than goes to the left. This arrow pointing is in the same direction as the inequality symbol. My second problem says m minus 13 is greater than 29. I will add 13 to both sides, isolating my variable m, and m is greater than, if I add 13 to the other side of the inequality as well, I'm going to get m is greater than 42. So when we draw a number line, if it doesn't have numbers on it already, we don't have to start with 0 in the center. We can start with any values. If this were my number line, I might have 40, 41, 42. I see I need an open circle, and if it's a greater than symbol, the numbers get greater, going to the right. Let's try 2 more. Now I see negative 11 plus x is greater than 9. In order to eliminate that, I need to add it to both sides. I get x is greater than 20. Last problem, we see that we have a subtraction again, so we're going to use the addition property of equality by adding 4. That states that 11 is greater than x, and you know that we have to write an inequality with the variable first, so we'll get x is less than 11. We've now had a chance to practice our addition and subtraction of inequalities. We're going to move on to multiplication and division of one steps next session. So until then, some problem for you to practice. Have a great day.